Hi everybody, and welcome to my video on the empirical rule. My name is Norman LeMay, and I would like to talk to you about a couple of things regarding this empirical rule. That is, there's kind of a couple of different things going on, meaning that there's this idea of this theoretical perspective and this practical perspective. So the idea under the theoretical realm is that if you have this bell-shaped distribution, there are these certain things that are met. Whereas, does that propagate, or how does that propagate over to the practical side? That is, if I have a true blue data set, and notice that this true blue data set is not going to be perfectly bell-shaped, but it's going to be approximately bell-shaped. So how does that approximation span, or how does that work out coming from this theoretical realm, from the empirical rule over here to the practical realm? So that's what I'd like to discuss in this video. And so please just continue to strive on with this. And as always, cue the music, maestro. Okay, everyone, I'd like to start off with the empirical rule and what you've taken a look at, seen, and read about. And that is, the empirical rule says that if you have this bell-shaped distribution, if you take a look at the center of the distribution and go out one standard deviation on either side of the mean, then you will have a grand total of 68% of the data. If you go two standard deviations on either side of the mean, you will have a grand total of 95% of the data. And if you go three standard deviations, then you will have 99.7% of the data. So these coverage intervals that you're going to construct refer to the data and the amount or the percentage of the data that should be contained in those intervals. So in this one, I've also shown a picture here how it breaks down. That is, from the mean to one standard deviation, there should be 34% of the data. If you go from one standard deviation to the right of the mean up to two standard deviations, then that means you should have 13.5% of the data. And over here, just to be a little different, if we come two standard deviations to the left of the mean over to three standard deviations, then we should have a coverage of about 2.35% of the data. So these coverage intervals work when you have an exact bell-shaped distribution. But what happens if you don't? And I'm so glad you asked. If you don't have an exact bell-shaped distribution, this is kind of a slight effect. All right, so this is the ages of presidents. So if you take a look here at this column, the ages of presidents at their inauguration. So here I have a data set of all 45 of the presidents, starting with George Washington at the very top here and Donald Trump down here at the end. And if you compute the summary statistics, then I came up with the summary statistic that the median is 55, the mean is 55, and the standard deviation of 6.5. And this is a histogram that I constructed, and we can see that we have this approximate bell-shaped distribution. So we should have some sort of an applicability of the empirical rule. And let's just go back and take a step back for a moment. And in our studies, we found that if we have a bell-shaped distribution, then the mean and the median should be the same, which also translates to our practical side, is that if we have an approximate bell-shaped distribution, then the mean and the median should be approximately the same. And in our case, we can easily see up here that the mean and the median happen to be the same. And that's really great. So that works out. But I do want to point out, it does not go the other way. That is, if the mean and the median are the same, it does not necessarily follow that the distribution is a bell-shaped distribution. So it's a one-way street. If you have the bell shape, then you can expect the mean and the median to be the same. If the mean and the median are the same, then it does not follow that you have the bell-shaped distribution. And that is why it's always important to construct a graph before you construct and interpret your summary statistics. So working with that, let's just notice that I have our theoretical percentages right here, right? So our 68, 95, 99%. So let's just note that if we go the mean plus or minus 6.5 standard deviations, then my lower bound here is 48.5. My upper bound here is 61.5. So let's just observe what that means. So let me open up this column here, and this column right here is the sorted data set. So let's just observe that if I actually come over here to the actual data, and I come over here from 48, and I come all the way down here to 61, all right, that means that from 48 to 61, notice that that count is 32. So I have 32 actual pieces of data in this interval. And if I take 32 and divide that by 45, my actual percentage is 71%. So notice that these are not exact. The actual of 71% is not exactly the same as the 68%, but they are pretty darn close. If I go 2 standard deviations on either side of the mean, so doubling the 6.5, I get 13. So 55 minus 13 is 42, plus 55 plus 13 is 68. So if I come over here and count all the data from 42 all the way down to 68, let's just note that I get 43 out of the 45, and 43 divided by 45 is 96%. And notice that that's even closer to our theoretical result. And then finally, if I go 3 standard deviations, which I believe is 19.5, then if I go 55 minus 19.5, it looks like I got a little typo here. It should be 35.5. So let me change that real quick. 35.5. And if I go add 13 here, I should get, let's see, 19.5 should be 74.5. Yeah, that's good. All right, but at the end of the day, let's just note that the smallest I can go is down here to 42, and the largest I can go is 70. So let's just note that all 45 pieces of data are contained, and I do get that 100%, which is awfully darn close to the 99.7%. All right, so I hope this helps to clear out between the theoretical and the practical. They're not going to be exactly the same, but there should be awfully darn close when you have an approximate. So this is why when we're on the practical side, we say we should have approximately 68%, we should have approximately 95%, and we should have approximately 95.7%, or I'm sorry, 99.7% of the data. Okay, so I hope this video helps you out and clears up between the theoretical component and the actual component.